Alright guys, so we are now ready to move on to our last section, that is rational number and irrational numbers. In your previous grade, you have already learned about what these terms mean. So let's do a quick revision of the same. So what do you mean by rational numbers? Rational numbers are numbers that could be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. So can you think of few examples of rational numbers? Here are a few examples. See, in all these examples, numbers are expressed in the form of P by Q, where P and Q are integers. So just to identify a rational number given in a fraction form, all you need to check is if it is given in the form of P by Q, where P and Q are integers. Now, what if the number is not given in the form of a fraction? If it is given in the form of a decimal, how would you identify whether it's rational or irrational? To understand this clearly, let's convert the examples into decimal form. So here it is. So what do you notice here? You can notice that some of the decimals are terminating and some others are non-terminating, right? So notice here that for non-terminating decimals, there is a definite pattern to it. For example, look at 7 by 11. What is its value? It is given to us as 0.636363. See, the number 63 keeps on repeating. Similarly, look at 22 by 7. What is its value in decimal form? It is given to us as 3.142857, 142857, 142857, and it keeps on repeating. Here also you can see that the number 142857 keeps on repeating. So, how do you identify a rational number if it is given in the decimal form? Here is what you have to do. You have to check whether the decimal is terminating. If it is terminating, it's definitely a rational number. If it is non-terminating, all you need to check is if there is a definite pattern to it that keeps on repeating. So, if there is a definite pattern that keeps on repeating, it means it could be expressed in some P by Q form and hence it would be a rational number. Now, I want you to think about this question. Are integers rational numbers? For example, consider 2. 2 is an integer, right? Is it a rational number? Now, if you look at it, we can easily see that 2 could be expressed in the form of 2 by 1, 4 by 2, etc. And all of these are in the form of P by Q, right? Where P and Q are integers. What does it mean? It means that any integer can be expressed in the form of P by Q. Why? Because any integer basically can be expressed as that integer by 1. So, all integers are rational numbers. Let's quickly sum up what we just discussed. Any number that could be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0, are rational numbers. This includes integers, terminating decimals, and non-terminating decimals with a definite pattern. That's all you need to know to identify a rational number. We will discuss why some decimals terminate and why some decimals do not terminate in a while. But before we discuss that, let's discuss what irrational numbers are. So what are irrational numbers? Simple. Numbers that could not be expressed in the form of P by Q are irrational numbers. You might recall some of the examples that you have learned in your previous grades. So here are some examples of irrational numbers. You can see that root 2, root 3, root 5, root 7, etc. are irrational numbers. These numbers could not be expressed in the form of P by Q, where P and Q are integers. Now, do you think root 4 is irrational? What is root 4? Root 4 is 2. Now, 2 is an integer. We have just learned that all integers are rational numbers. So, root 4 is also a rational number. In fact, you take any perfect square. 4, 9, 36, 64, etc. Square root of all these would result in an integer. So what does it mean? It means that square root of all perfect square are going to be integers and hence rational numbers. In general, we can state that square root of all non-perfect squares are irrational numbers. So, given any number in the radical form, that is the root symbol if it is there, you can easily identify whether it is rational or irrational number. But how do you identify an irrational number if it is given in the decimal form? To understand this, let's look at these examples and convert these into decimal form. So here it is. What do you notice? You can notice that all these numbers written in the decimal form are non-terminating. Now, can you find a definite pattern that keeps on repeating? Not really. So, all non-terminating decimals without any pattern. In other words, all non-repeating, non-terminating decimals are irrational numbers. So that's how you identify an irrational number if it is given in the decimal form. One other important irrational number is pi. Value of pi is shown here. You can easily see that it is never ending, that is, it is non-terminating, and it is also non-repeating because there is no definite pattern that you can see here. This means pi is an irrational number. So let's quickly sum up how to identify an irrational number. If the number is given within roots, all you need to check is if the number within the radical symbol is a non-perfect square. If it is a non-perfect square, it means that the result is going to be an irrational number. Similarly, if the number is given in the decimal form, what you need to check is if it is non-repeating and non-terminating. If yes, then that is going to be an irrational number. So that's how you identify rational numbers and irrational numbers if it is given in the form of a fraction, root, or in the decimal form.